Pierre de Fermat developed the technique of adequality to calculate maxima and minima of functions, tangents to curves, area, center of mass, least action, and other problems in mathematical analysis. According to André Weil, Fermat introduces the technical term adaequalitas, adaequare, etc., which he says he has borrowed from Diophantus. As Diophantus v11 shows, it means an approximate equality, and this is indeed how Fermat explains the word in one of his later writings. Diophantus coined the word pi alpha rho iota sigma tau eta sigma to refer to an approximate equality. Claude Gaspard Bachet de Meziriac translated Diophantus's Greek word into Latin as adaequalitas. Paul Tannery's French translation of Fermat's Latin treatises on maxima and minima used the words adaequation and adaequalitas. Fermat's method. Fermat used adequality first to find maxima of functions, and then adapted it to find tangent lines to curves. To find the maximum of a term, Fermat equated and after doing algebra he could cancel out a factor of and then discard any remaining terms involving to illustrate the method. By Fermat's own example, consider the problem of finding the maximum of. Fermat adequated with, that is, cancelling terms and dividing by. Fermat arrived at removing the terms that contained. Fermat arrived at the desired result that the maximum occurred when. Fermat also used his principle to give a mathematical derivation of Snell's laws of refraction directly from the principle that light takes the quickest path. Descartes' criticism. Fermat's method was highly criticized by his contemporaries, particularly Descartes. V. Katz suggests this is because Descartes had independently discovered the same new mathematics, known as his method of normals, and Descartes was quite proud of his discovery. Katz also notes that while Fermat's methods were closer to the future developments in calculus, while Descartes' methods had a more immediate impact on the development. Scholarly controversy. Both Newton and Leibniz referred to Fermat's work as an antecedent of infinitesimal calculus. Nevertheless, there is disagreement amongst modern scholars about the exact meaning of Fermat's adequality. Fermat's adequality was analyzed in a number of scholarly studies. In 1896, Paul Tannery published a French translation of Fermat's Latin treatises on maxima and minima. Tannery translated Fermat's term as adaequalitas and adopted Fermat's adaequation. Tannery also introduced the symbol for adequality in mathematical formulas. Heinrich Wheeleitner wrote, Fermat replaces A with A plus E. Then he sets the new expression roughly equal to the old one, cancels equal terms on both sides, and divides by the highest possible power of E. He then cancels all terms which contain E and sets those that remain equal to each other. From that, the required results. That E should be as small as possible is nowhere said and is at best expressed by the word adaequalitas. Max Miller wrote, thereupon one should put the both terms, which express the maximum and the minimum, approximately equal, as Diophantus says. Jean Itted wrote, one knows that the expression adaequalitas is adopted by Fermat from Diophantus, translated by Xylander and by Bachet. It is about an approximate equality. Joseph Ehrenfried Hoffmann wrote, Fermat chooses a quantity h thought as sufficiently small, and puts f roughly equal to f. His technical term is adaequare. Pierre Stromholm wrote, the basis of Fermat's approach was the comparison of two expressions which, though they had the same form, were not exactly equal. This part of the process he called comparare per adaequalitatem, or compare per adaequalitatem, and it implied that the otherwise strict identity between the two sides of the equation was destroyed by the modification of the variable by a small amount. This, I believe, was the real significance of his use of Diophantus by rho iota sigma omicron nu, stressing the smallness of the variation. The ordinary translation of adaequalitas seems to be approximate equality, but I much prefer pseudo-equality to present Fermat's thought at this point. He further notes that there was never in M1 any question of the variation E being put equal to 0. The words Fermat used to express the process of suppressing terms containing E was alido, delio, and expungio, and in French iefface and iote. We can hardly believe that a sane man wishing to express his meaning and searching for words would constantly hit upon such tortuous ways of imparting the simple fact that the terms vanished because E was 0. Claus Jensen wrote, moreover, in applying the notion of adaequality, which constitutes the basis of Fermat's general method of constructing tangents, and by which is meant a comparison of two magnitudes as if they were equal, although they are in fact not, I will employ the nowadays more usual symbol. The Latin quotation comes from Tannerie's 1891 edition of Fermat, Volume 1, page 140. Michael Sean Mahoney wrote, Fermat's method of maxima and minima, which is clearly applicable to any polynomial P, originally rested on purely finitistic algebraic foundations. It assumed, counterfactually, the inequality of two equal roots in order to determine, by Wiert's theory of equations, a relation between those roots and one of the coefficients of the polynomial, a relation that was fully general. This relation then led to an extreme value solution when Fermat removed his counterfactual assumption and set the roots equal. Borrowing a term from Diophantus, Fermat called this counterfactual equality, adequality, on p. 164. End of footnote 46. Mahoney notes that one of the meanings of adequality is approximate equality or equality in the limiting case. Charles Henry Edwards, Jr., wrote, for example, in order to determine how to subdivide a segment of length into two segments and whose product is maximal, that is to find the rectangle with perimeter that has the maximal area, Fermat proceeds as follows. First he substituted for the unknown x, and then wrote down the following pseudo-equality to compare the resulting expression with the original one. After cancelling terms, he divided through by E to obtain. Finally he discarded the remaining term containing E, transforming the pseudo-equality into the true equality that gives the value of x, which makes maximal. Unfortunately, Fermat never explained the logical basis for this method with sufficient clarity or completeness to prevent disagreements between historical scholars as to precisely what he meant or intended. Kirsty Anderson wrote, the two expressions of the maximum or minimum are made adequal, which means something like as nearly equal as possible. Herbert Bredger wrote, I want to put forward my hypothesis. Fermat used the word adequare in the sense of to put equal. In a mathematical context, the only difference between equare and adequare seems to be that the latter gives more stress on the fact that the equality is achieved. John Stilwell wrote, Fermat introduced the idea of adequality in 1630s, but he was ahead of his time. His successors were unwilling to give up the convenience of ordinary equations, preferring to use equality loosely rather than to use adequality accurately. The idea of adequality was revived only in the 20th century. In the so-called non-standard analysis, Enrico Giusta cites Fermat's letter to Marin Massena where Fermat wrote, Cette comparaison par adaequalité produit deux termes inégaux qui en fin produisent l'égalité qui n'austant la solution de la question. Giusta notes, in a footnote, that this letter seems to have escaped Bredger's notice. Klaus Barner asserts that Fermat uses two different Latin words to replace the nowadays usual equals sign, equibitur, when the equation concerns a valid identity between two constants, a universally valid formula, or a conditional equation, adaequalitas. However, when the equation describes a relation between two variables, which are not independent. On page 36, Barner writes, why did Fermat continually repeat his inconsistent procedure for all his examples for the method of tangents? Why did he never mention the secant, with which he in fact operated? I do not know. Katz, Schatz, Schneider argue that Fermat's application of the technique to transcendental curves such as the cycloid shows that Fermat's technique of adequality goes beyond a purely algebraic algorithm, and that, contrary to Brege's interpretation, the technical terms parasauts as used by Diophantus and adaequalitas as used by Fermat both mean approximate equality. They develop a formalization of Fermat's technique of adequality in modern mathematics as the standard part function which rounds off a finite, hyperreal number to its nearest real number. Bibliography. Breger, The Mysteries of Adequare, A Vindication of Fermat, Archive for History of Exact Sciences 46 to 193-219. Edwards, H. Jr. The Historical Development of the Calculus. Springer, Giusta. Les méthodes des maxima et minima de Fermat, Anne. FAC. Sci. Toulouse Math. 18. Fascicule Special. 59-85. Grabiner, Judith V. The Change and Concept of Change. The Derivative from Fermat to Weierstrass. Mathematics Magazine 56. 195-206, DOI 10.2307, 2,689,807. Katz, A History of Mathematics. An Introduction, Addison Wesley. Stillwell, Yearning for the Impossible. The Surprising Truths of Mathematics, page 91. A. K. Peters, Limited, Wellesley, M.A., Weil, A. Book Review. The Mathematical Career of Pierre de Fermat. Bull. Amer. Math. Soc. 79, No. 6, 1138-1149.